Headlines can paint a startling picture. They suggest China is transforming thousands of obsolete fighter jets into a massive drone swarm. Satellite imagery of rows of old fighters makes the claim vivid. This image captures the imagination, blending old technology with futuristic warfare. It speaks of a low-cost threat and a high-volume threat designed to overwhelm modern defenses. Is this a genuine strategic revolution in the making? Or is it a compelling story that has outpaced the complex reality of military engineering and operational planning? This essay will carefully examine the facts behind the headlines. We will look at what is truly possible and what remains in the realm of speculation. The central question is not merely whether old jets can be converted into drones. The core of the issue is their practical utility in a modern conflict. We must analyze the real-world advantages and the disadvantages of such a program. This requires understanding the history of the aircraft, the technical challenges of conversion, and the likely roles those airframes could play on a sophisticated battlefield. The idea of a J-6 drone swarm is a powerful one. It forces us to consider how aging hardware can be repurposed in the age of autonomous systems. It is a story about innovation, resourcefulness, and the changing character of air power. This analysis will proceed in a clear and factual manner. The Shenyang J-6 is an aircraft with a long and storied past. It is a Chinese-built version of the Soviet Mikoyan-Gurevich MiG-19. The MiG-19 first flew in the 1950s. The MiG-19 was the world's first mass-produced supersonic fighter. China began producing its own variant, the J-6, in the late 1950s. China continued manufacturing it for over 2 decades. For a long period, the J-6 formed the backbone of the People's Liberation Army Air Force. Thousands were built. It served as the primary interceptor and air superiority fighter during a critical phase of the Cold War. By modern standards, the J-6 is profoundly obsolete as a crewed fighter. It is a simple, rugged machine. It lacks advanced avionics. It lacks powerful radar. It lacks long-range missiles that define contemporary air combat. Its performance is limited. It has a relatively short range. Its design prioritizes speed and climb rate over maneuverability. Its twin engines were powerful for their time. Those engines are inefficient and maintenance-heavy compared to today's power plants. As China's military modernized, it introduced more capable aircraft like the J-7, J-10, Su-27. The J-6 was gradually phased out of frontline service. The last J-6 fighters were officially retired from combat roles in 2010. The primary motivation for converting old jets into drones is economic. Modern fighter aircraft are extraordinarily expensive. Fourth-generation jets can cost tens of millions of dollars each. Fifth-generation jets can cost even hundreds of millions. Purpose-built cruise missiles are costly, large attack drones are costly. In contrast, the J-6 airframes are already paid for. They are effectively a sunk cost, sitting in storage and representing zero procurement expense. While the conversion process itself is not free, the overall cost of creating a J-6 drone is expected to be substantially lower than manufacturing a new platform with similar speed and payload capabilities. This logic is about maximizing military mass on a constrained budget. Beyond cost, reusing old jets offers a way to generate a large volume of platforms quickly. Building new drones from scratch requires establishing production lines. It requires sourcing materials and manufacturing every component. By starting with a complete airframe plus the engine and landing gear, the conversion process can potentially be much faster. This allows for the rapid creation of a large, expendable force. The concept of military mass is important here. In some scenarios, the ability to launch hundreds of platforms at once can be more valuable than having a few highly sophisticated ones. Transforming a 1950s-era piloted jet into an uncrewed vehicle is a complex engineering task. The first and most critical step is to install a new flight control system. The J-6's original controls are purely mechanical and hydraulic. They are directly linked to the pilot's stick and rudder pedals. These must be replaced or augmented with electromechanical actuators. These actuators are small motors that move the control surfaces. Ailerons, elevators, rudder in response to digital commands. A central flight control computer must be installed to translate guidance signals into precise actuator movements, acting like a robot pilot inside the airframe. Once the physical controls are automated, the aircraft needs a brain and a way to navigate. This means integrating an autonomous navigation and guidance unit. It typically combines a GNSS receiver, like China's Beidou. The utility of a J-6 drone is directly tied to what it can carry. Given its origin as a fighter, the aircraft has several hardpoints on its wings and fuselage designed for carrying external stores. The simplest and most direct application would be to use the drone as a crewed cruise missile. The J-6 would be filled with explosives and programmed to fly into a high-value fixed target. Command Center Radar Installation Port Facility. Its speed and altitude profile would make it a challenging target to intercept compared to a traditional subsonic cruise missile. Its large airframe could accommodate a very large warhead, causing significant damage upon impact. A more sophisticated approach would involve equipping the J-6 drones with conventional munitions, unguided dumb bombs rocket pods. For this to be effective against anything but a very large area target, the drone would need a precise guidance system to ensure an accurate release point. A more likely option is the integration of modern, precision-guided munitions, satellite-guided small-diameter bombs, laser-guided small-diameter bombs, short-range air-to-surface missiles. This would allow the drone to stand off from a target and attack with greater accuracy, increasing its effectiveness and survivability. In addition to offensive weapons, the J-6 drones could be equipped with various sensors and electronic warfare payloads, electro-optical camera. Section 6. The Swarm in Action envisioned military roles. In a potential conflict, the primary role, first-wave saturation weapon. Main targets, layered air defenses, those protecting Taiwan naval carrier strike groups. Large numbers launched simultaneously, dozens, hundreds. Objective: overwhelm enemy sensors and interceptors. Radar can track only a finite number. Missile launchers have limited ready interceptors. A massive high-speed swarm aims to exceed that capacity, ensuring some platforms get through. Second key use, attrition warfare. High-end SAMs are extremely expensive. Patriot PAC-3, SM-6, J-6S are low-cost and expendable, forcing a tough defensive choice. Firing an expensive missile at a cheap drone is an unfavorable exchange. Section 7. Achilles heel. Limitations and vulnerabilities. Despite their potential benefits, converted J-6 drones have significant and undeniable weaknesses. Their most glaring vulnerability is their complete lack of stealth. The J-6 was designed in an era before low observable technology. Metal airframe, sharp angles, twin-engine exhaust, ground-based radar, naval radar at seafighter aircraft radar. This gives the defender ample time to track the incoming drone and engage it with long-range surface-to-air missiles, or with air-to-air missiles. Another major limitation is the reliability and performance of the underlying airframe. These are old aircraft with engines and structural components that are decades past their prime. The WP-6 engines are known to be maintenance-intensive and have a relatively short operational life. Even if well-preserved, the risk of engine failure, hydraulic leak, structural fatigue during a high-stress flight is considerable. An unacceptably high rate of attrition due to mechanical failure before reaching the target area could undermine the entire concept of a low-cost massed swarm. Section 8. A chorus of caution, expert views and strategic doubts. While the idea of a J-6 drone swarm has generated significant media attention, many Western defense analysts remain skeptical about its true operational impact. A common view is that while the concept is clever, its effectiveness would be highly situational. Experts point out that modern networked air defense systems are designed to handle saturation attacks. Systems like the U.S. Navy's Cooperative Engagement Capability, CEC, allow multiple ships and aircraft to share sensor data, creating a single integrated picture of the battle space. This allows them to allocate targets and interceptors efficiently, making it much harder to overwhelm them with numbers alone. Another point of contention is the cost-benefit analysis. While the airframes themselves are, free, the conversion process is not. Skeptics argue that the cost of developing, installing, and testing the new avionics actuators and data links, combined with the expense of maintaining and operating these old jets. Section 9. Conclusion. Distinguishing hype from reality. In conclusion, the story of China's J-6 drone conversion program is a fascinating mix of hype and credible threat. The core idea of turning thousands of retired fighters into uncrewed platforms is technically feasible and grounded in a logical desire to leverage existing assets for low-cost military mass. These drones could plausibly serve in specific high-risk roles, as first-wave saturation attackers to overwhelm air defenses, as decoys to draw enemy fire, and deplete missile stocks as simple, large payload delivery systems against fixed targets. Their speed and numbers could present a genuine challenge to defenders in certain scenarios. However, the reality of their effectiveness is tempered by significant limitations. These drones are not super weapons. They are non-stealthy, mechanically unreliable, and dependent on guidance systems that are vulnerable to modern electronic warfare. Against a sophisticated, well-prepared adversary, a large portion of any J6 swarm would likely be destroyed long before reaching its target. This balance between hype and reality is where a clear understanding of the J6 drone's potential truly lies.